Hello students, this is Dr. Anita Raj, your chemistry mentor, welcoming you for a new session in surface chemistry. In this session, we shall learn about the classification of colloids based on the nature of interaction between dispersed phase and dispersed medium. Okay, so based on that, we are having two types, that is lyophilic and lyophobic colloids, and let us see one by one now. Okay, so before going into the topic, I should teach you what are colloids. Okay, see, these colloids are the solutions which are intermediate state between true solutions and suspensions. Okay, and the particle size of these colloidal solutions will be ranging between 1 nanometer and 1000 nanometer. And examples for these colloidal solutions are starch, then a gum, gelatin, and also there are so many other examples coming under this colloids. Okay, so before learning this colloidal solution, you should know what are true solutions and suspension. Okay, see here, this is an example for true solution. Actually, in true solution, the dispersed particles will be having the size lesser than 1 nanometer. Okay, see in this, the dispersed particle will be having the size lesser than 1 nanometer. 1 nanometer means it will be, see here, it will be lesser than 10 to the power minus 9 meter. Okay, so the particle size will be lesser than this. Here the dispersed particle constitute a single molecule or ion. Okay, and example for this true solution is a salt in water. See here, if this is salt in water, see when you are mixing the salt in water, it will be completely dissolving and will be getting a true solution, so that the particle present in this solvent will be lesser, having the size lesser than 1 nanometer. Okay, so the pass here, the salt is the dispersed phase. Okay, and next one is the suspension. See here in suspension, it is entirely different from that of the true solution. It has the dispersed particle size greater than 1000 nanometer. Okay, so the size of the particle will be greater than 1000 nanometer. Okay, here, and which are aggregates of millions of molecules. Okay, it will be an aggregate of millions of molecules, and the soil particles, example soil in water is an example for suspension. Okay, so the particle size will be greater than 1000 nanometer. So this colloidal solution will be intermediate between this true solution and this suspension. See, this colloidal solution, it will be having the size of the dispersed particle ranging between 1 nanometer and 1000 nanometer, between 1 nanometer and 1000 nanometer. Understood? So the dispersed phase, or see the dispersed, what do you mean by dispersed phase? See, this phase consists of the particles. Okay, that is in colloidal solution, so it will be having the colloidal particles. And what do you mean by dispersed medium? It is the medium in which the colloidal particles are dispersed, okay, or seen or spread. Okay, so dispersed medium and dispersed phase are entirely different. Dispersed phase or the phase, it consists of the particles, and dispersed medium is the medium in which the colloidal particles are dispersed. Okay, so now you understood what are colloids and what is dispersed phase and what is dispersed medium. Understood? Now we can go into the topic. Okay. So classification of colloids based on dispersed phase and a dispersed medium. That is, that too based on the nature of interaction between the dispersed phase and the dispersed medium. Okay, there are two types under this classification. Lyophilic colloid, it's otherwise called as intrinsic colloid, and the next one is lyophobic colloid, and that's otherwise called as extrinsic colloid. Okay, let us see the difference between these two now. See, actually, these lyophilic colloids are, they are solvent attracting colloids. Okay, see here, the particles which are mixed, which are seen in this colloidal solution, will be having a strong attraction towards the solvent used here. Whereas here in the lyophobic colloid, they are solvent repelling colloids. Maybe that is, these particles, these colloidal particles, that is dispersed phase, will be it's not attracted by the dispersed medium. That's the meaning. Okay, so they are solvent repelling colloids. Okay, and next, it can be easily prepared. This lyophilic colloids can be easily prepared. This can be easily prepared by simply mixing the substance with the dispersed medium. Okay, so dispersed phase, here the dispersed phase can be easily mixed with the dispersed medium, and this type of colloid can be easily prepared, whereas this lyophobic colloids cannot be easily prepared. Okay, and the next one is, they are highly stable. Okay, they are highly stable and cannot be coagulated easily. See here, once if the lyophilic colloid is formed, it remains stable and that cannot be precipitated easily. It cannot be coagulated easily by using an electrolyte. Whereas here, this is less stable, mean it can be coagulated easily. See how it can be coagulated. They can be easily precipitated by using an electrolyte. Okay. So here I have taken example this ferric hydroxide FeOH thrice. This is an example for this type of colloid, that is lyophobic colloid or extrinsic colloid. This can be easily precipitated by using a electrolyte, sodium hydroxide even. Okay. Whereas this cannot be precipitated. Here the starch, as I have taken starch as an example for this lyophilic colloid, this cannot be easily precipitated. Okay. And the next point is dispersed medium is separated from the dispersed phase by evaporation. Understood? See, this dispersed medium can be easily separated from the dispersed phase. Okay. So this is a little reversible solutions, whereas here they are irreversible. Once if this is coagulated or precipitated, that is lyophobic colloid, once it is precipitated or once it is coagulated, cannot be reversed. It will not give back the colloidal solution by simple addition of the dispersed medium. Okay, it cannot be easily reversed. Okay, it cannot be easily converted to this lyophobic colloid once it is coagulated or precipitated. It remains as a coagulation, or it remains as a precipitate. Understood? And the next one is viscosity is much higher than the solvent. See here in lyophilic colloid, the viscosity is much higher than the solvent. What do you mean by viscosity? It is the thickness or the stickiness. Okay. So that is the internal friction offered to flow. Okay. So here the viscosity is much higher than the solvent. Okay. When compared to lyophobic colloid, because here the viscosity is same as that of the solvent which we are using. Okay. So the viscosity of this lyophobic colloid will be same as that of the solvent we are using, whereas here the viscosity will be much higher than the solvent we are using. Okay. And next one is they are highly solvated. They are highly solvated. For example, what in by solvation? Solvated or solvation. Solvation is the interaction of a solvent with a dissolved solute. Okay, interaction of the solvent with the dissolved solute. So in the case of water, solvation is often referred to as hydration. Okay, so this is highly solvated. See here, we can easily mix this with water, then it can be easily solvated, or starch can be easily solvated. Whereas here this is less solvated. Okay, this has less attraction. It has less attraction to the solvent. Okay, so they are less solvated. Understood, students? So highly solvated means as the particles they have greater affinity for the solvent here, whereas here less solvated means they are less solvated as the particles are having less affinity for the solvent or no affinity between the dispersed medium and the dispersed phase. Okay, there will be no affinity or no attraction or no interest between the dispersed phase and the dispersed mediums. That's why they are less solvated. And moreover, why these are more stable? This is due to the fact that these colloids are extensively solvated. Okay, these colloids are extensively or highly solvated, so that the particles are covered by the sheath of the liquid in which they are dispersed. Okay, so that means I hope you can understand. See, these lyophilic colloids are highly solvated. Since they are highly solvated, the colloidal particles are covered by the sheath of the liquid in which they are dispersed. Okay, that's why they are remaining highly stable. Okay, whereas since this is less solvated, they are less stable. Okay, that can be easily coagulated. Understood? See here in the lyophilic colloids, the surface tension is less than that of the solvent, whereas here in the lyophobic colloid, the surface tension is the same as that of the solvent. Okay, what do you mean by surface tension? Actually, it is the tension offered on the surface of the liquid due to the particles attraction which is present in the bulk of the liquid. This will lead to minimize the surface area. So the next point is the dispersed particles are neither visible nor can be detected easily under ultra microscope. See, the dispersed particles cannot be seen through our naked eyes, and that can also be not noticed under ultra microscope. Okay, we cannot easily see the dispersed particles in the case of lyophilic colloids. Whereas in the case of lyophobic colloid, the dispersed particles, though not visible, can be detected easily under ultra microscope. See here in the case of lyophobic colloids, the dispersed particles cannot be seen through our naked eyes, but it can be easily detected under ultra microscope. Understood? And moreover, the important point is the dispersed particles have little or no charge on them in the case of lyophilic colloids, whereas in this case, the dispersed particles carry a definite charge which is either positive or negative. Okay, so these are the differences between the lyophilic colloids and the lyophobic colloids. Okay, and these two types comes under the classification of colloids based on the interaction between the dispersed phase and the dispersed medium. Well, fine students, I hope you might have understood what I have taught today. Let me meet you with another important topic in my next session. Until then, it's Dr. Anita, Geochemistry Mentor signing off from you. Thanks for watching.